Hi friends, I'm Yakuta Karkhanawala. So today we are going to see the seventh operator, which is Bitwise Operator. Bitwise Operator, as the name suggests, it works on bits. Each number is been converted in sequence of bits. So this Bitwise operators will work on this bits. Bitwise operators can only be used in integer data type, that is whole. Bitwise operator cannot be used in float or double data types. It cannot be used with floating point numbers. It can be used only in case of whole numbers. So which are the different bitwise operators that are available are, first one is bitwise end, which is single ampersand. Double ampersand was logical and single ampersand is bitwise end. Then single pipe symbol, that is bitwise OR. Then bitwise XOR symbol, left shift operator, right shift operator. Left shift is 2 times less than sign. Right shift means 2 times greater than sign. And the last one is ones complement. So total 6 bitwise operators are available. Let's see one by one each of them. Bitwise end operator, that is single ampersand sign. In case of bitwise end operation, what we have, the result will get as 1 if both the bits are 1. If any of the bit is 0, then the result is 0. This is the truth table of bitwise end operation. That is, if I have two bits, one is A and B. If A and B both are 0, 0, then the answer is 0. If A is 0 and B is 1, that is, if any bit is equal to 1, then also the output is 0. But if both the bits are 1, then only you will get the output as 1. Say for example, how to use bitwise AND operation. I have a variable A which is having the value 60 and the variable B which is having the values 30. So A and B are of integer data type. Unsigned integer means they are positive numbers. The value 60 is represented in binary as 00111100, and the value 13 is represented as 4 times 0 1101. Now we have to perform AND operations, bitwise AND operations. So in this case, apply this rule as per the truth table given here. How you are going to apply is, the first bit of both the numbers are 0 and 0. So the output is 0. That is, if any input is 0, output is 0. Second bit is 0 and the second bit of both the numbers is also 0. So you will get 0. Similarly, third and fourth bit, it is 1, 1 and 0, 0. Since it is any bit is 0, the output is 0. So the first 4 bits we are going to get 0. Now let's see the next bit. Here we have both the bits is equal to 1. Means the output is 1. Then again we have both the bits is equal to 1. So the output is 1. And for the rest, since one of the bit is 0, so the output is 0. So the final result is 0, 0, 0, 4 times 0 and 1100. So whenever you perform A bitwise AND operation with B, then the answer is 12, which is assigned to the variable C. Let's see the next one, that is bitwise OR operation. Bitwise OR operator means that is single pipe symbol. In this case, the output is 1 if any of the bit is 1. If both the bits are 0, then the output is 0. So this is the truth table of bitwise OR. That is, if both the bits are 0, then the output is 0. If any bit is equal to 1, then the output is 1. Let's see the example, how you are going to use bitwise OR operator. So again, I have taken two variables A and B, which is equal to 60 and 30. This is the binary value of A and B. Apply the bitwise operation. That is, if both bits are 0, the output is 0. If any bit is 1, output is 1. So the first bit is 0, so the output is 0. Second bit is again 0, 0, so it is 0. The third bit is 1 and 0. That is, if any one bit is 1, the output is 1. So we get the output as 1. Similarly, 1, 0 is 1, 1, 1. Both the bits are 1, so the output is 1. and so on for the rest. So this value we get 61, which is stored in the variable C. Next is bitwise XOR operator. XOR operator means if both the bits are same, then the value is 0, the result is 0. If both the bits are different, then the result is 1. This is the truth table of XOR operator. That is, if both the bits are same, the output is 0. If if both the bits are 1, then also the output is 0, and both the bits are 0, then also the output is 0. But if the bits are different, okay, if it is either 0 1 or 1 0, then the result is equal to 1. The same thing you apply it as per in this program. That is, I have a is equal to 60 and b is equal to 13. This is the binary value, and apply XOR operations between a and b. Both the bits are 0, so the output is 0. Similarly for the second bit. In the third case, it is 1 0, so the bits are different, so the output is 1, and so on for the rest. So this is the answer 49, which is stored in the variable C, XOR operation. So we have seen three operators, bitwise operators, that is Bitwise End, Bitwise OR, and Bitwise XOR. Next, let's see the next operator, Bitwise operator, that is shift left operator. Shift left means shifting the bits of a variable on the left hand side. How many times you have to shift this particular bits is it depends upon the number of steps we have mentioned. How to use a shift left operator? I have a variable whose bits I want to shift left. How many times I have to want to shift that you have to mention it use in steps. That is variable, shift left operator and steps. Whatever result we'll get, it will be stored in result variable. Say for example, I have written a mathematical expression as result is equal to 5 is my value, which is stored in any variable, or you can directly mention here 5. I want to shift each bits of 5 left side. How many times? 2 times. So let's see how it will be carried out. 5. Now the binary value of 5 is 101. Okay, so 101. I'll convert this particular 3 bits data into 8 bits data because computer works in bytes. Bytes means 8 bits. So in order to convert this 3 bits into a byte or 8 bits format, what I'll do is I'll add extra zeros before 101. So this is, I've added extra zeros here. I want to shift each bit left. So the first bit, that is 1, is shifted left, right? So you have to start from the right hand side and put this particular 1 value on in the second position. This is the second position. First position right now is blank. We'll come to that later. Similarly, the second bit of the number 0 is placed, shifted left, means it comes to the third position, and so on the rest. One third bit is given to the fourth position, comes to the fourth position. This is fourth position, 1, 2, 3, and 4. Okay, and similarly, rest of the bits are shifted. Now, when we come to this last particular bit, then this bit, the last bit is discarded. Okay, it is deleted, or you can say it is discarded. Now, this one space is left. These are 7 bits, but I want to convert, I should have your data result in 8 bits. So, this particular, the first bit will be 0. I'll place it by default, I'll place it 0. So, all the bits you can see is been shifted left. That is, the first value is placed in the second position, that is left side. 0 is placed on the third position, and so on. And this first bit will become 0, and the last bit is discarded. This step, shifting of bit, was carried out for one time. We have to do it how many times? 2 times. So we'll take this result and shift it once more. So shift all the bits again once more on left hand side. So now this 0 comes to the second position, then 1 comes to the third position, 0, 1, 0, 0, 0. And this last 0 bit is discarded or deleted. And at the first position here, we'll get the value as 0. We have to place 0 by default here. So all the bits are shifted. So you can see this was the original value which was shifted once, and I got, instead of 101 I got 1010. When I shifted second time I got 10100. It means if you shift the number left by once, that is this one, it means that you are multiplying the number by 2. If you shift a number twice, it means you are multiplying by number 4. If you shift the number thrice, means you are multiplying the number by 8, and so on. So you can see the first number was our 5. When we shifted once, this is decimal 10, that is the double of 5 multiplied by 2 is 10. So that is 10 here, and this is the binary value of 10. Again, you shift 10 by once, so that becomes 10 into 2, that is 20. And this is the binary value of 20, and so on. So if you want to multiply a number by 2, 4, 8, and so on, you can use shift left operator. Instead of using multiplication, you can also use shift left operator. This advantage of shift left operator is that it is faster compared to multiplication operator. Now next is shift right operator. Shift right is just opposite of shift left operator. Means all the bits are shifted on the right hand side depending on the number of steps. So we have a variable which has to be shifted right by the number of steps, and the result will be stored in result variable. Say for example, again I am taking the same value, result is equal to 5, but this time I have taken the shift right operator, and how many times I want to shift this? Twice, 2 times. So this is my original number. For 5, the binary value is 101, and I've converted into 8 bits. In this case, now I want to shift all the bits on the right hand side. Right hand side means this should be my flow. So I'll start from the left hand bit. From this bit I'm going to start. So the first here, this 0 bit is placed on the second position, the next 0 on the third position, and so on. All the bits are shifted. Now the last bit, this one which has been left, is deleted or discarded. This is my empty space. These are only 7 bits. I have to convert it into 8 bits. So at this particular position, I'll enter 0. So now my 8 bits is when the number is formed. Now this shifting was done once, but we have to shift it how many times? 2 times. So that we'll do it once more. So this 0 is again placed on the second position. The next 0 is placed on the third position. Third 0 is placed on the fourth position, and so on. It has been carried out. And the last value, this particular 0, is discarded. And at this position, that is the first position from the left hand side, we'll put 0. Okay. So it means whenever you want to apply shift right operator, it means if we are shifting right once, means we are in this case dividing the number by 2. If we are shifting the number twice, it means we are dividing the number by 4. As you can see, the first we started with 5. So the decimal value was 5, and this was the binary value 101. After the first step, shifting operation, it means we are going to divide 5 by 2. So it becomes 2. Forget about, it won't be 2.5, but we'll take integer division, which becomes 2. Again, shifting this 2 once more means we are dividing 2 by 2, that becomes 1. So this is 1. So the binary value of 1 is all zeros and 1. The binary value of 2 is all zeros, and the last 2 bits is 1 0, and so on. So this was about shift left and shift right operator. Left means multiplying the number by 2. Shift right means dividing the number by 2. The last bitwise operator is ones complement. Ones complement is denoted by tilde sign. Ones complement means complementing or flipping all the bits of a number. Flip means converting the value 1 to 0 and 0 to 1. Say for example, I have the value in A is equal to 5. What is the binary value of A equal to 5? 5 is 101. and I've converted into 8 bits. So before 101 I placed 5 times 0. Now whenever we'll apply this tilde of the ones complement to this variable a, that is tilde a, it means I have to convert all the bits into the opposite one. That is, I will have to flip all the bits of this particular number. So 0 becomes 1, 0 becomes 1, 1 becomes 0, as you can see here. Okay, so the answer would be 5 times 1, 0, 1, 0. So this was ones complement, which is a very easy operator to work on. So this was all about bitwise operators. We have seen 6 bitwise operators: bitwise AND, bitwise OR, bitwise XOR, shift left, shift right, and ones complement. That's all for today. Thank you. Goodbye.